We're going to conclude this chapter section on the Pythagorean theorem and its converse by looking at about 3 theorems as well as, 4, including the triangle inequality theorem. And we're going to use this information to classify triangles when we know lengths of what may be the sides of a triangle. All right, so first let's look at the converse of the Pythagorean theorem, and it says if the squares of the lengths of the shortest sides of a triangle is equal to the square of the length of the longest side, then the triangle is a right triangle. So and that makes sense because a squared plus b squared equals c squared, and if it's a right triangle, the hypotenuse is going to be the longest side. And so if a squared plus b squared equals c squared, then the triangle is in fact a right triangle. Now, we can also determine from looking at the relationship of a squared plus b squared equals c squared as to whether we have an acute triangle, triangles that are not right triangles, as to whether they are acute triangles or obtuse triangles. So let's take a look at these. And these are Pythagorean inequality theorems. So if c squared is less than a squared plus b squared, then the triangle is an acute triangle. And if c squared is greater than a squared plus b squared, then the triangle is an obtuse triangle. So if a squared plus b squared equals c squared, we got a right triangle. If c squared is less than a squared plus b squared, then we have an acute triangle. And if c squared is greater than a squared plus b squared, then we have an obtuse triangle. Now, one last thing is the triangle inequality theorem. So let's take a quick look at that before we do some classification. Now, in the triangle inequality theorem, if the sum of the lengths of any two sides, it says the sum of the lengths of any two sides of a triangle must be greater than the lengths of a third side. And if that's not the case, we don't have a triangle. In other words, they're not going to all connect at various vertexes. So we're going to start, as we're classifying triangles, first we're going to try to determine whether this set of numbers, these sets of numbers, can even be a triangle. And then if it is, then we're going to classify it, whether it's acute, right, or obtuse. So here we have side lengths of 3 segments, 11, 60, and 61. And we want to first apply this triangle inequality theorem to determine, is this even a triangle? So that means that the length of any two sides has got to be greater than 61. Now let's start with 11 plus 60. Well, obviously that's greater than 61. Okay. And, 60 plus 61 is certainly greater than 11. And then the last two match these two. 61 plus 11 certainly is greater than 60. So we know at least we've got a triangle. Now we're going to determine whether a squared, which is the 11, 60 squared, which is the b squared, if it is equal to, greater than, or less than 61 squared. So let's see, we got 11 squared plus 60 squared, and we got 61 squared. So I'm going to use my calculator. Well, I know 11 squared is 121. And 60 squared is 3,600. I don't even need a calculator for these. But what about 61 squared? I'm not quite as sure about that. 61 squared is 3,721. All right, well, let's see. Well, 121 plus 3,600, well, that is 3,721. So that equals, so a squared plus b squared equals c squared. All right, well, since a squared plus b squared is equal to 21, then this has got to be a right triangle. because a squared plus b squared equals c squared. We're going to look at two more, and I know you cannot wait. All right, well, I'm definitely going to need my calculator on this one on the left. So I got 2 square root of 3, 4 square root of 2, 3 square root of 5. So let's see, what is 2 square root of 3 plus, well, we'll do that, plus 4 square root of 2. Well, let's see, that equals 9.12, if I round it to the nearest hundredth, 9.12. So let's see, 2 square root of 3 plus 4 square root of 2. What's its relationship to 3 square root of 5? So 2 square root of 3 plus 4 square root of 2 is 9.12. All right, and I'm going to think about this 3 square root of 5. All right, so, well, 4, if it was a square root of 4, that'd be 3 times 2, that'd be 6. So that'd be less than 9.12. In other words, 9.12 is greater than 3 square root of 5. And let's see, if it was 3 square root of 9, that'd be 3 times 3. That'd be 9, and 9.12 certainly would be greater than that. So it's got to be greater than 3 square root of 5, but just for fun, 3 square root of 5. I really don't have to figure this. I could reason that out. Well, 912 is greater than 6.71. All right, so then I probably should do 2 square root of 3 plus 3 square root of 5. 2 square root of 3 plus 3 square root of 5. That equals 10.17. When I compare these two, 10.17. Well, 4 square root of 2, I mean, that's less than 2. I mean, square root of 2 is less than 2. So 4 times, let's say even 4 times 2, that'd be 8. That's less than 10.17. So that part checks. Let's then check these two. 4 square root of 2, 3 square root of 5. 4 square root of 2 plus 3 square root of 5. That equals 12. Well, 2 square root of 3, 12.37 actually, 12.37. Well, that's still got to be greater than 2 square root of 3, right? There's no way that 2 square root of 3 could be greater than 12. So we do have a triangle. So now we're going to determine how we're going to classify it. And again, we're going to set this up as 2 square root of 3 squared, a squared, plus 4 square root of 2 squared, b squared. And what's its relationship to 3 square root of 5 squared? Okay, so 2 square root of 3 squared, well, that's 4 times 3 when we square that, plus 4 square root of 2, well, that's 16 times 2. And then 3 square root of 5, well, that's going to be 9 times 5. So let's see what we got. 4 times 3 is 12. 16 times 2 is 32. And 9 times 5 is 45. And 12 plus 32 is 44. 44 to 45. Well, 44 is less than 45, right? So, c squared is 45 is greater than a squared plus b squared, which according to the triangle inequality theorems, then this triangle must be obtuse. And you may want to go back and review those inequality theorems. So when anytime c squared is greater than a squared plus b squared, which is what we see here, then it's an obtuse triangle. Okay, so let's see here. Well, now we've got 6.2 and 13.8 and 20. That should be a comma right there, by the way. Okay. All right, well, let's see. Let's test it to see if this is even a triangle. Well, 16.2 plus 13.8. Well, that is actually 20. And so that'd be 20 equals 20. Well, any two sides, according to the triangle inequality theorem, any two sides must be greater than the third side. And 20 is not greater than 20. 20 equals 20. So no, this is not a triangle. Man, I enjoy this. I know you do too.